All right, let's just dive right in. We're living in this incredible age where AI can write code, whip up amazing art, and do things we never thought possible. But there's this really strange paradox at the heart of all of it. Sometimes, the smarter and more confident an AI sounds, the more spectacularly wrong it can be. So let's unpack why that is.
So picture this. You ask an AI a really tough question, it thinks for a second, and then comes back with this. Sounds pretty certain, right? That phrase, "I'm pretty sure," it's just so reassuring. It's meant to make you feel like it's both smart and sure of itself. It's exactly what you want to hear. But what if it's not correct?
Yeah, it wasn't. Not even remotely close. And that, right there, is the core of AI's confidence problem. See, the model wasn't just wrong, it was confidently wrong. It led you down a completely false path, but with all the assurance of an expert.
And that really brings us to the big question, doesn't it? What is going on under the hood that lets these absolutely brilliant systems fail with so much conviction? You know, this isn't just some simple glitch. It's a fundamental challenge in AI, and we really need to get to the bottom of it.
Okay, so to figure this out, we've got to talk about something called the confidence trap. This is basically where our own human intuition gets all tangled up with what the AI is telling us.
And that brings us to this key idea, the fluency trap. So think about it. Large language models are trained on just massive amounts of human text. Their whole goal is to get really, really good at predicting the next word in a sentence. And because of that, they're incredible at mimicking how we talk. They sound so fluent, so convincing. But here's the trap. That fluency is super deceptive. It makes us lower our guard and just trust what they're saying, even when there's absolutely no factual basis behind it.
And you can see the difference pretty clearly here. On one side, you've got fluency. It sounds human, it writes well, it's persuasive. But on the other side, you have reliability. It's factual, it reasons things out logically, and this is a big one. It admits when it's not sure. The crucial thing to get is that these two things are not the same. An AI can be super fluent while being completely, totally unreliable.
Okay, so recognizing the problem is one thing, but how do we actually fix it? Well, the first step is to systematically map out exactly where and how these failures are happening. And that's precisely what a group of researchers decided to do with a project they're calling the CoData Project.
And listen, they didn't just look at one model, no. They tested a whole range of the industry's heavy hitters. We're talking the GPT series, Gemini, DeepSeek, Qwen, you name it. The whole idea was to find the weak spots, no matter which model we're talking about.
I just love this quote from their work because it really gets to the heart of the mission. This isn't about, just bashing AI. It's about making it better. The point is, for an AI to become a tool we can actually depend on, it has to learn its own limitations first. It needs to know when it's getting in over its head.
So the mission became pretty straightforward. They set out to build this totally unique dataset that documents these very specific kinds of failures. We're talking about times when the AI confidently hallucinates, just makes stuff up, or when its own logic kind of backs it into a corner, basically reasoning itself into a wall.
Now, by creating this data set of failures, the goal wasn't to score the models and see which one wins. No, this project is a totally different kind of benchmark with a completely different purpose in mind.
Yeah, this isn't about flexing accuracy or creating some kind of leaderboard. It's about building a diagnostic tool, something that helps us understand the actual nature of these AI blind spots. Ultimately, this whole project is just a big data-driven reminder of our main point here today, and it really highlights a critical new skill for all of us, which is learning to question and verify what AI tells us no matter how good it sounds. We just have to remember, fluent does not equal reliable.
Okay, so we've identified the problem, we've documented the failures, so what's next? Well, this is where the project turns into this incredibly powerful tool for actually building the next generation of AI.
And the process they've come up with is actually pretty simple and really collaborative. So, step one, it starts with the community. People like you and me. Find and document these confident failures. Step two, developers and researchers can just download this growing dataset to find the exact weak spots in their own models. And finally, step three, all that shared knowledge gets fed back into development, and that helps everyone train AI that's more robust, more honest, and at the end of the day, more reliable. It's this awesome feedback loop.
And maybe the best part of all this is that it's an open invitation. Seriously, anyone can get involved. You can go explore and download the data set yourself right now on Hugging Face. You can use it in your own projects to train better models. Or you can contribute your own findings and help grow this really crucial map of AI's blind spots.
And that kind of leaves us with one last thought to chew on. This whole journey to make AI more reliable, it's really about teaching it a kind of intellectual humility, right? The ability to recognize and just admit when it's wrong. So for teaching our most advanced creations how to see their own errors, what can that process teach us about seeing and overcoming our own confident blind spots?